Let's prepare to do pages 12, 13, and 14 in your Proportions and Ratio book. Starting with page 12. I'm going to do something a little bit different this time. I want you to put your pencils down. We're going to go through these 4 sample problems together. I don't want you to write anything at this point. So pencils down, all you have to do is watch. We will get the answers and I'll have you do them together afterward, but first I want you to just watch. Starting with number 4, 24/80 equals x over 60. 24/80 equals x over 60. Let's begin. I went ahead and worked on this. Let me show you what I did. I followed the standard rules. I did the cross multiplication. I multiplied 24 times 60 and I got 1,440. X times 80 and I got 80x. Then to get x by itself, I divided both sides by 80. You see all the work I did just to multiply. And then I had to do a nice, impressive long division problem. And in the end, after all that work, I got x equals 18. So here is how I got number 4, the answer for number 4, using the standard algorithm. Let's look at number 6. Start off with cross multiplication. 50 times d is 50d. 10 times 100 is 1,000. To get d by itself, I divide both sides by 50. Here is my work to show you. 1,000 divided by 50 is 20. So then I know that in this problem, d equals 20. It's a lot of work with some big numbers. Number 13, 33/99 equals 21x. Here is the standard algorithm. And that's a lot of, that's some big, heavy-duty multiplication right there. So 33x equals, and then we've got 99 times 21. Here is my work. It's a big, lengthy multiplication. And I got 2,079. So 33x equals 2,079. Now to get the x by itself, I will divide both sides by 33. Which means I've got to do some serious long division. 2,079 divided by 33. Fortunately for you, I went ahead and did that already. There you go. 2,079 divided by 33 is 63. So finally, I have my answer that x equals 63. Now, I'm doing this really fast, but it took me a long time to prepare for this video because it took a long time to do all of these, as you can probably imagine. On to number 14. 48/80 equals x over 5. First step, cross multiply. 80 times x, that was easy. 48 times 5, well, I had to do the work here. 48 times 5 is 240, so I can go ahead and write out 240. Then to get the x by itself, I will divide both sides by 80. Now I've got a nice hefty division problem, which I did. All this to discover that the answer, the value of x, equals 3. Got it? So just to review, what I learned is these values for each of the proportions I solved. Now, with that introduction, with that explanation of the standard procedure for finding proportions, now let me show you the way I think you should do it. I've not seen a textbook or a program that teaches it this way. I don't know why. But let me show you what I perceive as the easy way to do it. Let's look again at number 4. 24/80ths are reducible. I know that 8 goes into both 24 and 8. So before I do anything, I'm going to reduce. I'm going to reduce this fraction right here. 8 goes into 24 3 times. 8 goes into 80 10 times. So then I have a new proportion. 3/10 equals x over 60. Now get this. Now I can do equivalent fractions. 10 times 6 equals 60. So 3 times 6 would be 18. This is so much easier. I cannot impress upon you enough the importance of reducing fractions. Always, always reducing fractions first. Number 6. You got some big numbers here, but you know what? You can reduce this by 50. 50 is half of 100. 50 divided by 50 is 1. 100 divided by 50 is 2. Your new proportion is 1/2 equals 10 over d. Once again, you do equivalent fractions. 1 times 10 is 10. 2 times 10 is 20. Down to 13. I can see this in my head. I'm going to give you 2 options for this, for reducing that. So first off, you could look at that and say, I know 11 goes into both of those. So you could reduce it like this. If you divide them both by 11, you get 3/9. Then you can also reduce that. 3 goes into both 3 and 9. And then you end up with 1/3. Now, if you're really good with numbers, you can see that 33 goes into 99, and you could have reduced it by 33. But it's okay to take more than one step to reduce it to its simplest form. So if I reduce 33 divided by 33 is 1. 99 divided by 33 is 3. My new proportion is 1/3 equals 21 over x. 1 times 21 is 21. 3 times 21 is 63. Isn't that infinitely easier? And now 14. I look at this and I can readily see that 8 goes into both of those. 8 goes into 48 6 times. 8 goes into 80 10 times. So I'm going to do a similar thing with this. So 48/80ths. If I reduce that by 8, 48 divided by 8 is 6. 80 divided by 8 is 10. You see, that's still reducible. So I'm going to reduce it again by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. The reason that we had to reduce it twice is because the ideal number to reduce it by would have been 16. but not many people look at those and think, hey, 16 goes into both of those. So this is how I would have done it. I don't look at those and think 16 goes into both of those. This is truly how I would do it. I would reduce by 8, and then I would reduce again by 2. So 48/80ths becomes 3/5. And we have x over 5. Well, look here. 5 times 1 is 5. 3 times 1 is 3. So I showed you the standard way to do these, and then I showed you the easy way. Remember, no matter what, anytime you're dealing with fractions, it's just so much easier to reduce first because all your numbers are smaller. That's number 12. I should add that I learned this approach from a student. I had taught him from before kindergarten, and in 6th grade when I introduced him to proportions and I was teaching him this standard algorithm in the textbook, he said that, oh, I don't need to do that because I know if I reduce this, it's simply 1/3, and then I can just find the equivalent fraction. That was his idea, and I kind of thought about it and I researched it and discovered that, yes, that will always work. Honestly, some of the best approaches that I use, I think, I've learned from students. So anyhow, I thought that might interest you. On to page 13 for some word problems. We are doing numbers 2 and 5 together. I also helped you set up number 4. We are making proportionate ratios from word problems. And this is how I want you to set them up. Every time we've done these, I always have you do the same format. You do the labels first, and then you do the proportions. So, for example, number 2, 54 pounds of juicy gummy bears cost $450. You know what? I think I need to go buy some of that. $450. How many pounds of bears can you get for $50? No, I want 54 pounds for $450. I don't want only 50 pounds of gummy bears. Gummy bears are awesome. Okay, sorry, back to the problem. So, the pounds cost. So we'll start with pounds on top over cost. So we have 54 pounds. We know that 54 pounds costs $450. We want to know how much for $50. Now, where do I put the 50? Do I put it on top or the bottom? $50, which is cost, top or bottom? Bottom is cost, so we put 50 down here, just like that. And so we'll put P up here for pounds. We want to know how many pounds for $50. We've got some big numbers. You want to end up dividing this by 450? I'm going to say not. I can look at that and I know right away that 9 goes into both of those. 9 goes into 54 6 times. 9 goes into 45 5 times with a 0. So 6/50ths. I could reduce that more, but I see that this is also 50. So it would be easiest just to keep it like this. So 50 times 1 is 50. 6 times 1 is, 6. That made it incredibly easy. So for $50, you could get 6 pounds of gummy bears. I don't know, I'm stuck on that 54 pounds. Look at number 4. In case there was any doubt, I just kind of set up the labels for that. Students with 2 siblings, compared to students with one sibling. And then go ahead and do those. Number 5, I want to do that with you. It's the tricky problem. A lot of times you'll see ratios like this. And ratios are something that you encounter in real life a lot. I know my son was in chemistry, in high school chemistry. I think it was in honors chemistry. It was 10th grade. And I remember one of the things the teacher emphasized was how important the use of ratios was for chemistry. So this is something that you'll use for a long time, and it applies to a whole lot of different things. So it's definitely something that you want to feel confident with, and have a good, strong mastery of it, because you'll use this a lot. I use this a lot in real life. The ratio of boys to girls in 6th grade is 3 to 5. If there are 45 girls, how many students are there in 6th grade? Warning, this question is harder than it looks. Read it carefully. Okay, if you try to do this in one step, and you think it can be done in one step, then you weren't paying attention. Warning, tricky problem. This question is harder than it looks. Read carefully. Gives you a whole lot of encouragement to focus on the intricacies of this problem. It's not difficult. You just have to pay attention to what it says. That's really all it is. It's not difficult at all. The ratio of boys to girls. So now that I've read the whole problem, I know that I can set it up like this. The ratio of boys to girls in 6th grade is 3 to 5. When I write these, I like to read it over and over again to make sure I don't confuse any of my numbers. That's why you see me reading it and then rereading it and rereading it before I write something. It's a good habit. If there are 45 girls, how many students? Well, this is set up to find out how many boys. It's not set up to find out how many students. But if I find out how many boys there are, then I can put them all together and figure out how many students. So even though this right here does not answer the question, this step will get me to the answer. So let's continue with this. So we'll put a B up here for boys. This is already reduced. This is easy. 5 times 9 is 45. 3 times 9 is 27. So we know there are 27 boys. There are 45 girls. So how many in all? 7 plus 5 is 12. 4 plus 2 is 6, plus 1 is 7. There are 72 students in all. Take a moment. Be careful on this one. I feel like it's a little bit tricky because the ratio you set up is 12 aspens to 16 pine trees. But then it asks for how many, if there are 12 pine trees, how many aspens? In the original setup, there are 12 aspens. But they want to know how many aspens if there are 12 pine trees. When you set it up, it'll all be easy. Just make sure you put that 12 right here in the right place. We'll go over 2 together just, as a reminder, but you got this part. We'll do, at the top, we'll do C just because that is a decimal. This cannot be reduced, so we're going to do the cross multiplication method in its entirety. that method does get used, and it will need to be used. So that's why you need to know how to do it. It's just not always the best method because it can be the most tedious. So 11 times h is 11h. 5 times 6 and 6/10. Let me come over here. 5 times 6 is 30. 31, 32, 33. 33. I have one digit to the right of the decimal, so I'm going to have one digit to the right of the decimal. So I have 11h equals 33. And that makes sense because if you take off the decimal, that's just more than 6. 5 times 6 is 30. So it makes sense that if you a little bit more would give you 33. To isolate the h, isolate means to get it by itself, we'll divide both sides by 11. That's easy. H equals 3. So it would be 3/5. And down to number 1. I've told you this before, but just in case, when you're finding equivalent ratios and they're written like this, if that confuses you, go ahead and write them in fraction form. I'm going to put the first one on top. 14 over 5 equals 42 over x. This cannot be reduced. 14 does go into 42, but you may not know that. So I want to make sure I use a strategy that will work for you. So let's go ahead and do the standard algorithm on this one. 14 times x equals 42 times 5. That's not too difficult. 42 times 5, 10, 21. 14x equals 210. We divide both sides by 14. So now let me come over here, do myself a little long division problem. This page has plenty of room for you to do all your work. So 14 into 210. 14 goes into 2 0 times. 14 goes into 21 one time. 1 times 14 is 14. 21 minus 14, well, 7. 7 times 2 is 14. 7 times 3 is 21. I don't even need to subtract. Bring down the 0. Let me think. 14, 20. Okay, I'm going to guess 5 because it ends with a 0. And I know 4 times 5 is 0, so I'm going to guess 5. Let me do a little checking. So 14 times 5, I feel confident about this. Times 4 is 25, 6, yep, 70. Okay, I was pretty sure about that. So it's 5. So then, right here is 15. That's my answer, 15. X equals 15. You got 12, 13, and 14.